Researchers in Sydney just cut into donated human hearts and discovered something that should have made front-page news in every country in the world. The hearts of people who had type 2 diabetes didn't just look like any other diseased heart. They had been physically rebuilt. The muscle fibers were stiffer. The energy systems were broken. Fibrous scar tissue had crept in and replaced healthy, flexible heart muscle, millimeter by millimeter, over years. And the worst part? Most of these people had been taking their diabetes medication every day, hitting their blood sugar targets, and thought they were doing everything right. The study came out of the University of Sydney and was published in Embo Molecular Medicine. For the first time, researchers got a close, deep microscopic look at exactly what diabetes does to the human heart at the cellular level. And what they found directly contradicts the story most people with diabetes have been told for the last 30 years. Your doctor has probably told you that if you keep your blood sugar under control, you'll avoid most of the complications. Manage your A1C, take your metformin, watch your carbs. But this new research shows the damage to your heart muscle can start long before your blood sugar numbers ever cross into the dangerous zone. By the time your doctor is circling an elevated A1C on your lab report, the remodeling inside your chest has already been happening for years. Stay with me, because what you're about to learn will change how you think about both conditions. And I'll tell you exactly what to do about it before the end of this video. Dr. Benjamin Hunter and Associate Professor Sean Lowell at the University of Sydney School of Medical Sciences partnered with St. Vincent's Hospital in Sydney. They collected heart tissue from two groups. The first was people undergoing heart transplants because their own hearts had failed. The second was healthy donor hearts. They broke each group down further by whether or not the person had type 2 diabetes. The researchers used 3 techniques to examine the tissue. They measured protein levels inside the heart muscle cells. They ran RNA sequencing to see which genes were being turned on or off, and they used confocal microscopy, a powerful 3-dimensional imaging technique that lets scientists see the physical architecture of heart tissue in a way nobody had ever mapped before. What they found was striking. In people who had both diabetes and heart disease, the heart muscle showed a completely different molecular signature compared to people who had heart disease without diabetes. It wasn't just worse heart failure. It was a different kind of heart failure with its own unique fingerprint. The diabetic hearts were producing less of the proteins needed for muscle contraction. They were handling calcium differently, which is critical because calcium is the signal that tells heart muscle to squeeze. And their mitochondria, the tiny power plants inside every cell, were under massive stress and struggling to keep up with the energy demands of a working heart. The implications should be keeping diabetes doctors and cardiologists up at night. There's a medical term for what the Sydney team observed. It's called diabetic cardiomyopathy. The word cardiomyopathy just means disease of the heart muscle itself, as opposed to disease of the blood vessels or the valves. And diabetic cardiomyopathy specifically refers to the kind of heart muscle damage that happens because of diabetes, independent of whether you also have blocked arteries or high blood pressure. Here's what it looks like inside your chest. A healthy heart muscle is flexible and elastic. The fibers can stretch and contract smoothly thousands of times a day. Think of it like a fresh, well-oiled hand pump. It squeezes easily, the spring bounces back, and the water flows. Now imagine that same pump after years of rust creeping in between the moving parts. The spring gets stiff. The handle doesn't return as quickly. You have to pump harder to move the same amount of water. And even then, less water comes out with each stroke. That's what a diabetic heart starts to look like. The muscle becomes infiltrated with fibrous connective tissue, which is basically scar tissue. This fibrous tissue is rigid. It doesn't stretch. And the more of it there is, the harder it becomes for the chambers of the heart to fill properly between beats. The Sydney researchers used confocal microscopy to see this buildup of fibrous tissue, and they saw it even in people whose diabetes had been considered reasonably controlled. Dr. Hunter said explicitly that diabetes wasn't just a coexisting condition with heart disease. It was actively accelerating the heart failure by interfering with the essential biological processes that keep the heart muscle working. And the changes don't stop at the physical structure, which brings us to the part most people with diabetes have never heard before. Let me tell you about Barbara. Barbara was 68, a retired high school librarian who had been living with type 2 diabetes for almost 20 years. She managed it carefully. She checked her blood sugar twice a day, took her metformin every morning, went to every doctor's appointment, and kept her A1C at 6.8, which her endocrinologist called excellent. Her blood pressure was controlled. Her cholesterol was in range. On paper, Barbara was a model patient. Then over the course of about a year, she started noticing that she couldn't walk her dog around the block without getting winded. Climbing the stairs to the second floor of her house left her needing to sit down and catch her breath. She blamed it on getting older. Her doctor told her she probably needed to lose a few pounds. She tried walking more. But the shortness of breath got worse, not better. Her ankles started swelling in the evenings. Finally, her daughter convinced her to see a cardiologist. The echocardiogram told the whole story. Barbara had heart failure with preserved ejection fraction, also known as HFpEF. It's a type of heart failure where the heart is still technically pumping okay, but it's become so stiff that it can't relax and fill properly between beats. Her diabetes, despite being well controlled by every standard measure, had been slowly stiffening her heart muscle for 2 decades. Nobody had ever warned her this was possible. She'd been so focused on managing her blood sugar that she had no idea her heart muscle itself was being rebuilt the entire time. Barbara's case isn't rare. Studies estimate that up to 40% of people with type 2 diabetes show signs of diabetic cardiomyopathy on imaging, even without symptoms, which means there are millions of people walking around right now, taking their medication, hitting their targets, and quietly developing the kind of heart muscle damage that eventually shows up as exhaustion, swollen legs, and a cardiologist appointment nobody saw coming. To understand why this is happening, you need to know how a healthy heart gets its energy. Your heart is the most metabolically active muscle in your body. It never stops. The cells of your heart muscle have tiny power plants called mitochondria that convert fuel into energy around the clock for your entire life. Under normal conditions, your heart runs mostly on fats with some glucose and ketones for backup. It's a flexible engine that can switch between fuel sources depending on what's available. But diabetes changes the rules. Because your cells become resistant to insulin, the heart muscle cells can't efficiently take in glucose the way they're supposed to. The Sydney researchers found this resistance isn't just a metabolic inconvenience, it's a crisis. The mitochondria in diabetic heart cells were showing signs of severe stress, essentially running on broken equipment while still being asked to produce the same amount of energy. When a cell is under that kind of metabolic stress year after year, it starts to fail in specific ways. Proteins that should be built for muscle contraction don't get made in the right quantities. Calcium handling, which is what tells the muscle when to squeeze and when to relax, becomes sluggish and irregular. And over time, the tissue around the dying cells gets replaced with fibrous scar tissue. The body's default response to damage it can't repair properly. This is the microscopic mechanism by which diabetes rebuilds your heart into something stiffer and less efficient. It's not a blood vessel problem, it's a muscle problem, which is exactly why managing blood sugar isn't enough to protect you. For decades, the gold standard for measuring whether your diabetes is under control has been the A1C test. It's a blood test that gives you an average of your blood sugar levels over the past 2 to 3 months. If your A1C is below 7, most doctors will tell you you're doing fine. And for a lot of metabolic outcomes, that advice has been reasonable. But the Sydney research and a growing body of evidence behind it suggests that A1C is a blunt instrument. It gives you an average, but it doesn't tell you how much your blood sugar is swinging up and down throughout the day. It doesn't tell you about fasting insulin levels, which can be chronically elevated for years before blood sugar itself ever looks abnormal. And most importantly, when it doesn't tell you anything about what's happening inside the tissues that are actually being damaged by the metabolic dysfunction, like your heart muscle. You can have a perfect A1C and still have chronic high insulin, which drives inflammation, thickens artery walls, and contributes to the fibrous remodeling of heart tissue. You can have a perfect A1C and still have insulin-resistant heart muscle cells slowly starving for usable energy. And you can have a perfect A1C while the very process of insulin resistance quietly reshapes the architecture of your left ventricle. This is the uncomfortable truth the Sydney research has surfaced. The standard diabetes monitoring we've been doing for the last 30 years is aimed at a single number on a single test, and that number doesn't capture what diabetes is doing to your heart. And if you want to know the real state of your cardiovascular health as a person with diabetes or prediabetes, you need more than just an A1C. Here's the part of the video where I give you something you can actually use. Protecting the heart muscle itself requires a different approach than just trying to lower your blood sugar number. First, and this matters more than almost anything else, is reducing insulin resistance at the tissue level. Walking after meals for just 15 minutes has been shown in multiple studies to significantly improve post-meal blood sugar and insulin sensitivity. Strength training 2 or 3 times a week builds muscle, and muscle is the largest sink for glucose in your body. More muscle equals better glucose disposal, which takes pressure off the whole insulin system. Second, cut down on the kind of refined carbohydrates and seed oils that drive chronic inflammation. Your heart muscle is extraordinarily sensitive to inflammatory damage, and processed foods made with refined sugar and industrial oils are pouring fuel on that fire every day. Swap them for whole foods, olive oil, fatty fish, and plenty of vegetables. Third, ask your doctor for tests that go beyond a standard A1C. A fasting insulin test can tell you whether your insulin levels are chronically elevated even when your blood sugar looks normal. A continuous glucose monitor worn for 2 weeks shows you exactly how your blood sugar is behaving between meals, overnight, and during exercise. And if you're over 55 and have had diabetes for more than 5 years, ask about an echocardiogram to check on the structure and function of your heart muscle before symptoms appear. Fourth, be aware that certain newer diabetes medications have heart protective effects beyond blood sugar lowering. SGLT2 inhibitors and GLP-1 agonists have been shown in clinical trials to reduce heart failure hospitalizations in ways older medications don't. If you're on metformin alone and also have risk factors for heart disease, it's worth asking your doctor whether a newer class of drug might fit your full cardiovascular picture. For years, diabetes and heart disease have been treated as 2 separate problems. One set of pills for your blood sugar, another for your blood pressure, maybe a statin for cholesterol, and a hope that if the numbers line up on paper, the damage will stay away. But this new research out of Sydney makes it clear that diabetes isn't just sitting next to heart disease. It's actively rebuilding the heart muscle itself into a weaker, stiffer, less efficient version at the microscopic level, starting long before anyone notices. You now understand what diabetic cardiomyopathy actually is, how it develops, and why managing a single number on a single lab test isn't enough. You know about the Sydney study, the fibrous tissue buildup, the mitochondrial stress, and the insulin resistance that starves heart muscle cells from the inside out. You know what tests to ask for and what choices you can make to protect the muscle, not just the blood sugar. That kind of knowledge is worth holding on to.